Right. Okay, allegedly we are live. Ta-da! Hello. I'm eating chips. Just let me know if you can see me down there. It says stream health is orange. I'm not sure. I'm not sure why. Does everything look okay? Okay, right. If everything's cool. No, what it says stream health is orange. I can see and hear you. Good. I apologise for the crunching sound of me eating my chips. Right. So who have we got here? Just let me know who you are so I know who I'm talking to here. I got Mark. I'm assuming one of you is Gabriel. And maybe Tom? Hayden. It's close. That's fine, you can be anonymous if you want to. Yeah, that's cool, whatever. Right. Okay. So yes. So I figured that I mean, you guys said, "Oh, let's start off with pseudocode." I thought I'd have a look in the spec, just to have a look, because they have some guidance on like the pseudocode format that they're going to ask in the exam. Now, when I was looking in the spec at the Pseudocode Guidelines, I discovered something that you might think, oh wait, that's kind of cool. So, if you just bear with me a second, I will bring the spec up so we can have a look at it. Nope. Well, that's no good, is it? Where's the... Okay. And as if by magic, I have a browser. Can you see that text okay? In the thing. If you can't see that text, obviously you have access to this document on the classroom. This is page 33. Well, it says 33 in the bottom right corner. It's actually page 39 if we're going by the actual page number. Okay, so pseudocode, Boolean logic, and flowcharts. This is a sort of guideline because, as I've said time and time again, there is no set format for pseudocode. And I know I said, yeah, make it sound like a Russian guy explaining something in basic terms. You can do it that way, but after reading the exam board guidelines, which are sort of new this year, it's fairly Python-y. So the following guide shows the format pseudocode will appear in the exam components. It is provided to enable teachers to provide learners with familiarity before the exam. Learners are not expected to memorize the syntax of this pseudocode, and when asked, may provide answers in any style of pseudocode they choose, providing its meaning could be reasonably inferred by a competent programmer. Okay, the guide below shows languages and Boolean logic that will be used in the external assessments and indicates the limits and scope of each. Centers are free to go beyond these parameters. So this is a guideline. This is the guideline that they are going to be following in their questions. Okay, so if you have an algorithms question which is written in pseudocode, it's going to look like this. Let me scroll down. Variables and constants. Variables and constants are assigned using the equals operator. It looks exactly the same as Python there, right? Variables and constants are declared the first time a value is assigned, exactly like Python. They assume the data type of the value they are given, exactly like Python. Variables and constants that are declared inside a function or procedure are local to that subroutine. Again, exactly like Python. Variables in the main program can be made global with the keyword global. Okay, now that's a kind of a Python-y thing, but the way that they are doing it here is slightly different to the way that it's done in Python. Just sound off, do you guys know the difference between a global variable and a local variable? Okay. No, it is not the reason you were taught Python. You were taught Python because it's a great first language to learn, and it's very it's very popular in the real world. So, right, the difference between a local variable and a global variable. It's pretty simple, and the clue's in the name. A global variable can be accessible from any part of your program. Okay, if I declare a global variable called name and I set it to Bob, it doesn't matter what function I am in. It doesn't matter whether I'm inside a loop, outside a loop, whether I'm like halfway through 5 different functions. I will be able to access that variable and change it, and it will update it for the entire program. A local variable is one which is defined inside a function and only exists while that function is active, or it's defined inside a loop and only exists while that loop is happening. So as an example, what we got here, if I did something like name equals Bob, yeah, I could do something like def rename name equals John. Okay. This program that I've just typed in here, it will take that global variable here and it will print out the name that we have assigned it here. So at this point in time it's Bob. In fact, if I did a print name here, it's gonna, the output from this program is gonna say Bob, and then I can do it's gonna say Bob, I've defined this function, okay, and all this function does is it takes this global name and renames it to John. So the output from this program will be Bob and then John, right? Now if I didn't have that global name in there like that, if I just had name, right, this will create a local variable called name, okay, and then when I print it, it will still print out Bob, because that local variable only exists for the duration of that function. Okay, so a global variable is a variable which is accessible to any part of the program at any time. A local variable is one that only exists for the duration of a function or a loop. So another thing we could do is name equals John. Let's start off with, okay, and I can do print name, and then I could do for I in range 20. No, that's not going to work. I'll say other name equals Jim. This is a poor example. That should really be in a function. Let's call it a function. Function's called foolish because it's a stupid example, but the fact remains the same, right? Other name, if I try and do this, in theory, that would throw up an error, because this other name only exists during that, while that function is being activated. Okay? Hello everybody that's just joined us. We've just been going over local and global variables. Okay, so just back to the pseudocode that we had here. You will know if a variable is defined as a global variable because it will have global in front of the name. Okay. Casting. That means converting from one type of data to another. Oh, look at this. It's literally exactly the same as the way that it works in Python. Okay, so when you're writing your pseudocode, pretty much all the stuff you can do, it looks like you can just write Python. In fact, even outputting to the screen, it's print. Just like in Python, the formatting is exactly the same as in Python. Okay, print hello, print my age. Taking input from the user, variable equals input prompt to user. That is the same as Python. Now, I fundamentally disagree with what the exam board's doing here, right? But at the same time, this is helping you guys out because you don't have to get as confused about what's it called, pseudocode as you were before. So the other thing as well that I will just mention, this is the bit that's different. Okay, in fact, if I copy that and paste it down here. So here's an example of a little bit of pseudocode which is different to how it was done in Python. Okay, for I equals 0 to 7. Now, the pseudocode's at the top. The Python example would be for I in range 7 colon print hello or something like that. Okay, so just look at the difference between the exam board specified pseudocode here and the Python code here. Okay, so although almost everything seems to be pretty much the same as Python, for loops and while loops are different. I can see the chat, right guys, but I'm not going to stop explaining what I'm doing just because you guys are chatting, right? The great thing about me doing a live stream is that I don't have to talk over the top of people. You either take away the information that I'm getting or you don't get anything out of it, right? This is, I'm taking up my time to help you out, so yeah, take it or leave it. Okay, so the way that this works, for I equals 0 to 7, print hello, and then next I, that's like saying that's the end of the for loop. Okay, with the while loop that they've specified, they have done it like this. And this is spilled onto separate lines, but you get the idea. So while answer does not equal computer, you'll notice there's no colon at the end there, and there is an end while at the end to mark the end of the while loop. Everything again indented where it needs to be indented. Okay, so if I just get rid of, are you happy for me to get rid of the different for loops, or maybe I'll just do this underneath and then we can scroll back to it. So in Python, the way that we do that would be something like while answer does not equal computer colon, and then again exactly the same, answer equals input. What is the password for this example? Okay, but notice in Python you don't have that end while there, right? In the pseudocode you do, and that's the main difference between the Python code and the pseudocode as specified by the exam board here. Okay. Just a word, if I feel that people are not really contributing to the chat in a meaningful way, I'll just mute them or kick them out. Okay. Sorry, no. All right. So let's just have another quick look. This here, these first 3 lines, this is the pseudocode guidelines as given by the exam board. For I equals 0 to 7, print hello, next I. Okay, so if there is a for loop in a question that they have set, this is the format that it will take. Okay, this, however, is what it looks like in Python, which you are all used to. So when you're writing your pseudocode, try to avoid using range. Okay, the exam board does say that you don't have to use their exact format of pseudocode, but if you just use Python, you might run into problems. Okay, and the while loop, just like the for loop, we start off with the while and we end with an end while. Okay, so with the for loop, the end is next I, or obviously if that was J, it would be next J, or if it was lemon, it would be next lemon, and so on. While loops just end with end while. Okay, let's have a look down here. This is another thing that they might put in pseudocode, which is not actually in Python. Okay, so let's have a look at this. Do. So do answer equals input, what is the password, until answer equals computer. Okay, do we get what's going on there? This is very similar to a while loop, but a do loop will always execute at least once. Yes, exclamation mark equals is like saying not equal to. Okay, that's covered in the next section. So if you're not sure, obviously we've got 2 equal signs is equal to. Equal to. We've got exclamation mark or bang equals is not equal to. We have that is obviously less than. That less than or equal. We've got that is greater than. That is greater than or equal to or equal. Those are the comparisons that they will use, and they are exactly the same as Python. Okay? So once again, just remember, if you see this weird do until, remember it's going to do that at least once. Okay? So that's not a structure that exists in Python natively. So just be aware of that. Okay. How many marks is pseudocode worth? It depends on the question. It depends what they're asking. The question itself will have it's usually between 4 and 6 marks. Any pseudocode question, they will usually give you a mark per. If they're after a loop, they're going to give you a mark for using the correct type of loop. They'll give you a mark for getting the logic correct, and so on and so forth. Right. Logical operators and, or, and not. You know how to use them, right? So if radius is less than 5 and radius is greater than 0, yeah, do something. End if. There's an example. Okay, you know how they work. I don't have to go over those, right? Now, the arithmetic operators in the exam board pseudocode, slightly different to Python, although mostly the same. We've got that, which is add. We've got that, which is subtract. We've got that, which is divide. And we've got that, which is multiply. Okay? No big changes there, right? Now, whereas in Python we would use that, can someone tell me what that represents? Excuse me, can someone tell me what that represents in Python? It's not part of. It is what's known as modulus. Okay, that is also known as remainder. Yeah? If I do 12 modulus 5, okay, 12 divided by 5 is 2, remainder 2. Okay, so 12 modulus 5 equals 2, because it's the remainder when you divide. So when you divide the first number by the second number, what is remaining is the modulus. Okay? Now, that's what it looks like in Python. In pseudocode, doesn't look like that. It looks like that, which is easier to remember. Okay? Mod, modulus, remainder. Okay, so make a note of that if you need to. The other one as well, which is in Python, is that. Does anyone know what the double forward slash is? It's good bread. Changeberry bread. Poppy seeds. Good. Anyone know what double forward slash is? Say no if you don't. Okay, double forward slash is divide, right? But you discard the remainder. It's integer division. Okay, so using my example again, right? If I did 12 divided by 5, right? The answer is 2.4. I mean, that's the answer with a straight division, right? But if I hello Michaela, if I do double slash, okay, it's the same as just 2. Okay, so it's just you divide this number by that number and discard any remainder. Okay, now the exam board in their pseudocode, they will write it like this: div. Okay, which is pretty easy to remember. It's what's known as the quotient. Okay, which means divide and discard the remainder. Okay. Why discard the remainder? Well, there might be times when we want to divide a number by another number and get an integer result. So, for instance, if we were counting the number of pixels across the screen, or we were charting the movement of an icon across the screen, for instance, you can't have half a pixel, right? So, if it's moved a certain amount, but it hasn't quite reached the next pixel, we can't say move it halfway across that pixel. We can't move it across until we fill it, like, you know, completely past the thing. Okay, so it's when you need to do division, but you have to deal with integers. Okay, as an example, digital clocks. Digital clock doesn't tick up until it hits the full number. Okay, so there are a number of other practical uses for it. But yeah, I mean, I think it's probably unlikely that either mod or div will turn up, but just so that, you know, in case you see them and you think, oh, what's that? You know, there's that. Now, the only other one that they mention in this guide here, in Python, it's written like this. Does anyone know what the 2 stars next to each other mean? It's kind of similar to multiply, but it's not quite the same. 2 stars next to each other, what's that? It's not specifically square, but you're thinking along the right lines. If I did 2 and then 2 stars and then 2, it would be square. If I did 2 stars and then 3, it would be cubed. It is powers, yes. Okay, so 2 raised to the power of 3. Now that's how it's written in Python. In the exam board specified pseudocode, it's 2 raised to the power of 3, like that. Okay, it's a little circumflex. Caret, it's called sometimes, or hat. Okay, yeah. You might think that it's written like pow, but it's not. It's like that. Okay, so it's technically known as exponentiation, like that. Okay. Now, to answer your question, Callum, is paper 1 completely about pseudocode and system architecture? No, it is not. System architecture comes into it. Pseudocode will possibly come into it, but it's more likely to come up on paper 2. Okay, but the overwhelming request at the start was, can we go over pseudocode? And I just wanted to reassure you by showing you how similar. Yeah, I kind of gathered that, Tom. It's how similar to Python the pseudocode that the exam board will accept is. Okay, and obviously when I mark your mocks, this is the guide that I'm going to be using. Okay, just following down here, we've got if-else statements. If entry equals A, then print blah 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 blah. So if I just copy this whole if block here so you can compare it with Python, let's have a look at what's different. Yeah, well done. What's that? Don't need that. Right. Okay, so this is how the exam board will specify their if statements. Okay, so remember, this is not any specific programming language. This is the exam board's pseudocode. Okay, if entry equals A, then. So whereas in Python you would have a colon, in the exam board pseudocode you've got a then. Okay, but everything else looks pretty much the same. Instead of elif, we've got the full else if. Okay. And else is just normal. Things to remember, it ends with an end if here. Okay, end if. So yeah, this if the person has entered A, it will print out you selected A. Otherwise, if they entered B, it will print out you selected B. Otherwise, it will print out I didn't copy this bit. I think on the original it said unrecognized selection or something along that. Yeah, unrecognized selection. Now, there is one other thing in the exam board pseudocode, and it is a structure which does not exist in Python. Now, I'm assuming that Mr. Hawley has taught you about switch case statements. Does that ring a bell? Are you aware of what these things are? Let me know while I eat this piece of bread. Too much butter. Don't assume we know anything from Mr. Hawley. Oh. I mean, you guys have got so many notes, and so I refuse to believe that it hasn't been covered. But here we go. So this is a code structure which has no equivalent in Python other than a bunch of if-elif blocks. So it's not quite the same as that. Okay, it's called a switch block. Okay, switch and then it says switch entry. Now entry refers to the variable that we are comparing. Okay, so whereas before we had if entry equals blah 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 blah, we're saying take whatever the value entry is. Case is like saying if it equals this, okay, do this. Okay, you can replicate the the functionality of a switch block using dictionaries. Okay, so yeah, it's a similar sort of thing. Okay. So what this means is this is functionally equivalent to that if statement that we just had. Okay, so if entry is equal to A, we're going to print out you selected A. Okay, if it's not equal to A but it is equal to B, we're going to print out you selected B. Default is like the else statement. It's like if anything else, if it hasn't hit any of these things, then do this. Okay, and then obviously end switch marks the end of it. Now, there's way more to switch blocks than that. What's the gain from using this? As it stands there, there's not really much gain to using it. But there's something called fall through, which is what makes switches very useful. I mean, there's a massive debate in the programming community over whether switch blocks should be in Python or not. C++ programmers say they definitely should. Python programmers say no, it muddies the code. I mean, I think that switch blocks are a good thing when used properly, but there's not always it's not always necessary to use switch blocks. Okay, because you can have situations where like the way that fall through works, you can have situations where it will do a number of different things. I mean, it allows you to sort of change the priority of some of these different things. You guys don't need to know about that at this stage. All you need to know is that they're functionally similar to if, elif things. What's your view on indentation requiring languages? I think indentation is a good thing. Even if your language does not require indentation, I would recommend using it because it makes your code that much more readable. Python is much easier to use than C++. That is correct. Python is much easier to use than C++. But C++ is much faster and much more powerful for doing things like direct memory manipulation and things like that. But the thing is, like, any programming language, there is no sort of like one best programming language. Okay, it's like saying, oh, a hammer is the best tool. It's like, well, it depends what you're doing. A hammer's not going to be much use for chopping a block of wood in half. Okay, so the programming language that you choose is always about what you want to do with it. But yeah, personal preference plays into it as well. Scratch, yeah. Okay, right. Now this is where the pseudocode examples in the specification sort of differ slightly from Python. There's these bits on string manipulations, right? Now in Python, if I wanted to get a substring, let's say I had a string called name equals Mephistopheles. Everyone loves Mephistopheles, right? It's Faustus's dog. We know who that is. Welcome, James. Don't worry about being late. The whole stream is going to be available after it's finished anyway, so you can go back and review it. We've literally spent the last half an hour going over pseudocode and just how similar to pseudocode Python is, in the spec, which is available on the classroom for you, all of the at the back, page 33 onwards, there's a whole bunch of stuff with some guidance on what the pseudocode is going to look like. Okay, so some minor differences from Python, but okay. So I've got my name Mephistopheles. If I wanted to pull out like this fist, P-H-I-S-T, okay, I could do something like print name, and then it's the 1, 2, third letter going on 3, 4, 5, 6, 7. So I would do something like, wait, 0, 1, 2, no, it would be 2, idiot. 0, 1, 2, 3, 4, 5, 6, so I could do something like that, right? And that would pull out a substring from this string here, okay? String slicing, okay? Now, the exam board's guidance on pseudocode is totally different to that. Totally different. And so that's the bit that you might want to do a little bit of reading on. Because what they say is this. Right? Let's say I've still got that. So I'll put in brackets here. That's the Python way. Let's do the pseudocode way. So I've still got this name equals Mephistopheles. I'm still going to be pulling out the same substring, right? I would do something like this. Print name dot substring, and then its starting position 0, 1, 2 again, but instead of the finishing position, it's the number of characters. So 1, 2, 3, 4, 5. So I would put 2, 5. Okay, and that there is the pseudocode way. Okay, now remember, guys, just because this is the way that they do it in the book, that doesn't necessarily mean that that's the way that you have to do it. But bear in mind, this is definitely the Python way, and if you use that, they might throw it out. Okay, if you write in pseudocode, it's best to follow their guidelines for it. But you are more likely to... Sorry, I messed up. There should be a bracket there. You are more likely to encounter them having written this in some pseudocode that you have to read than a question where they expect you to write this. Okay? So things to bear in mind. With Python, it's the starting character and the ending character, non-inclusive, right? With the exam board pseudocode, it's the starting character and the number of characters. Okay, I am going to cover other topics. I just wanted to finish off with some of these points that might trip you up. Okay, because I don't want to spend like the whole time just going over pseudocode. But I appreciate that pseudocode is the thing that keeps you up at night. So yeah. Function definitions in the pseudocode, instead of def and then the function name, it's pretty much the same, but they use function like this. So function triple number is the example that they've got here. Return number times 3, and then end function. Okay, I mean, you could read that and derive the meaning from it. Okay, that is functionally equivalent to the Python def triple number return number times 3. Okay, same thing. Okay, so what else have we got here? Arrays. The way that arrays are accessed, it's exactly the same as Python lists. Okay, so if I have a array equals, I don't know, 3, 6, 5, 7, like that. Okay, I could do print array 3. And that would print out, well, one of you guys tell me, if I was to do, if I had this array 3, 6, 5, 7 and I did print array 3, what would that print out? Yes, it prints out 7. Okay, you guys have got that, you don't need to worry about it. One thing though, are you familiar with the concept of 2D arrays? Yes or no? Two-dimensional arrays. Okay. Doesn't matter if you're year 10, it's good learning for you. Who are you, out of interest? Alright, so two-dimensional arrays, each item in the array is an array itself. Ah, Harrison, nice one. You can have a house point for that. Good stuff. Each item in the array is an array itself. Okay, so for instance, if I did, if I had my other array and I did this, okay, here's my first item. It's also an array. I'm going to say 2, 3, and then I have a separate item here, 4, 6. Okay. Right, so let's just process this, right? The array, which is called array, only has 2 elements in it, right? If I was to do print array 0 like this, what would that print out? Yeah, well, technically it would print out 2, 3 like that. It would still have the square brackets around it. It would print out like an array. Okay, because this whole thing is the first unit, right? But we can access different elements of the array. Now, really annoyingly, the exam board uses a totally different way of accessing it compared to literally every other programming language in the universe. Okay, and it's like, why would you do that? But that's what they do. I will show you the way of doing it in Python, because that's sort of like the proper way, and then you guys can I will show you the pseudocode way. Okay, so let's say I just want to print out that's the second item of this first element. Okay, I would do it like this. We're accessing the first element, right, which is this one, element 0, and then I want to print out the second element in this list, which is element 1, so I would do it like that. Okay, if I was to run that in Python, I should hasten to add, that would print out 3. Okay, let's just break this down. We are accessing the array. We're accessing the first element in the array, which is this. Okay, we are then accessing the second element in that element, so it would print out 3. Does that make sense? Does that make sense? Yes or no? Yes. Yes? Good. Okay, now, here's the bit that's really going to annoy you all. The way that the exam board is likely to write this in their pseudocode is not like that. Okay, they will do something like this. I can't type. Array... they would do 0, 1, like that. Okay, now I can't really think of any programming languages that do it that way. Almost all of them that I know do it this way. Okay, so in a way it's good because I mean it's fairly straightforward, but in another way it's bad because it's completely different to the way that you do it in Python. But it is what it is, so just be aware that two-dimensional arrays are a thing. They will probably not expect you to create a two-dimensional array, but they might expect you to comprehend a two-dimensional array from some pseudocode. Okay? So, we're almost at the end of this section on pseudocode. Right? Opening files. They use their own specific terminology for opening files. Now in Python, I do something like I might do file equals open myfile.txt, open it in read mode, for instance. I might do something like that, yeah, and then I'd do like, you know, file.read, and then file.close, or whatever I'm doing, yeah. Okay, so that's how we would do it in Python. Now, the way that they do it in the pseudocode is fairly similar, but they use a slightly different syntax for actually opening the file. And in a way, they do it in I think it's easier to comprehend in their pseudocode that they've got here. The example that they put here is my file equals open read, which presumably is like their thing, sample.txt. Okay, so that's equivalent to saying file equals open sample.txt, comma r. Yeah, and then they would do x equals my file dot readline, which is pretty much the same as Python. Okay, not quite the same commands, obviously, and then obviously my file dot close. Okay, that's how they're doing it. Now, again, you don't have to memorize these exact commands and stuff like that. If you are not sure, you can just put open my file for reading. Okay, what I'm saying is they have all this like specific stuff, right? But as I said right at the start, they will accept other stuff as long as it makes sense, as long as any reasonable programmer would be able to look at it and say, yeah, I know what that means. Okay? So yeah, well, they have defined it. So to answer your question there, Tom, don't you need to define how you want to open the file like in Python? Yes, you do. And they've used open read because they have a separate method. So they might do my file equals open write. I can't spell open write. I don't know, let's call it xxx.txt. Sounds like a file my brother would have on his computer. Okay, so so that's how they do it. But again, don't panic if you're not sure how to do it. Just say something like open my file for writing. Okay, as long as you are clear and what you've written is unambiguous, that's fine. Are programmers reasonable people? Some of them are, not all of them. So yeah. No, my brother was actually arrested for burglary, but it was when he was, how old was he? I think he was about 12 years old, and he didn't actually rob anything. He broke into there was an abandoned warehouse, and there was a window open, and he went in there and he set off a fire extinguisher, and someone called the cops on him. So he spent the night in a cell and was absolutely terrified, and then came home and was good as gold for the rest of his life. So there you go. Anyway, that's it. Okay, now the only other difference, and this is actually something I approve of, strangely, if I was to do something like this in Python, what would it be called? Okay, I've written that line of code. What is that referred to as? A comment. That is correct. Technically correct, Callum. Yes, it is text, but specifically it is a comment. Now, the way that the pseudocode in the exam board is going to be written, you would use that. And I hear you say, "Oh, but wait, that's the symbol for like, you know, integer division." It's like, well, yeah, it is, but remember in their pseudocode they are going to write div when that happens. Okay, so this is a comment, and the reason why I approve of that is because that's how comments are written in C# and C++ and Java and a multitude of other languages. Okay, so yeah. And also, top tip, if someone's saying something and you don't like what they're saying, if you hold your fingers up like that, it looks like 2 forward slashes. Yeah? Or should it be the other way? That way, yeah. And so if you get it so that those 2 forward slashes are in front of their mouth, then it comments out what they're saying. So maybe not. Okay, anyway. So yeah, I suppose you could do that. Does that look like a hash symbol? I don't know. Anyway. Right, that's basically it for pseudocode, right? So my advice on the pseudocode subject is, number 1, don't panic. Number 2, most of the stuff is very similar to Python anyway. Number 3, if you're not sure what to write, just write it in English, but in the clearest terms possible. Simple, right? People make a massive deal over pseudocode and they really don't have to. I've never really understood it. If you can write Python, you can write pseudocode. Because pseudocode is like Python, but you don't have to be grammatically correct. Give me a house point. Who are you? I don't even know who you are. I don't have a Captain Motzo in my class. Who are you? Matthew Williams. Okay, well, I hope this is interesting for you, Matt. I'll give you a house point if you get something out of it. Right, so let's just go back to the topic at hand. For the past 45 minutes ish, we've been talking about pseudocode, and that's useful because you're likely to get algorithm questions on both tomorrow's mock and Monday's mock. Okay, so I now throw the floor open to you guys. What do you want me to cover? Remember, tomorrow's mock is going to cover the following subjects: systems architecture, memory, storage, wired and wireless networks, network topologies, protocols and layers, system security, system software, ethical, legal, cultural and environmental concerns. Which section of that do you want me to go over? Okay. Right. So looks like networks is a thing. Okay. Ethical and legal. Okay. I'll go over some of that stuff in a sec as well. Now, things to bear in mind. I've covered most of this this stuff already. I'm not going to recover the stuff that we've already covered in too much detail. Right. Is there anything specific about networks that you want to know about? Obviously, we did some stuff on DNS and DDoS and stuff like that in the lesson today. So I'll tell you what, I can go through this stuff and you can yell out, "Wait, do that." Okay. Network protocols. Are we clear what network protocols are? Just say yes or no. Or yell out a network topic that you want me to cover. Okay. What protocols do you know? Things to bear in mind with what protocols you know. If there's an S in the protocol, it's probably it probably stands for secure. Okay. Okay, so there's a few of you yelling. Right. Okay, so I will quickly cover protocols, and then I've got some stuff on topologies down here as well. Okay, so we will get to those in a secondo. Okay, so a network protocol. If you do not have this definition memorized, you need to memorize it. Okay, network protocols are sets of rules which explain how to transmit different types of data across a network. That is the textbook definition of a network protocol. If you get a question saying, what's a network protocol? If you write down network protocols are sets of rules which explain how to transmit different types of data across a network, you will get 2 marks. Boom. Done. Okay, be more specific there, Tom. A set of rules for transmitting data, yes, but remember it's a set of rules for transmitting different types of data across a network. Okay, so you've got to be precise here. Why do we need network protocols? Well, we need network protocols because there's lots and lots of different types of data. Okay, how many marks for Tom's answer? 1, probably 1 mark for Tom's answer. Okay, because it needs that specifics. Yeah, and I'm harsh when it comes to marking, but the reason I'm harsh when it comes to marking is so that it doesn't seem so bad when you ace the exam. Okay, I did a thing, yay. Okay, so we need network protocols because there's lots and lots of different types of data flying across the internet. Remember, the internet and the World Wide Web are not the same thing. Okay, lots and lots of people think the World Wide Web is the same thing as the internet, but it is not. Can any of you tell me what the difference is between the World Wide Web and the internet? That was me trying to smile. I'll tell you what, guys, right? Maybe have a think. I'm just going to go and make myself a cup of coffee because I'm literally dying, right? I was at work for over 10 hours and I got back late and all I've had to eat is just some bread and some chips. Okay, so yeah, the answers are coming in now. Right, the World Wide Web is mainly websites. The World Wide Web is totally websites. That's all it is. Okay, internet is the connection. It's the wires, it's the cables, it's the actual infrastructure on which the data is traveling, right? The web is data transition, the internet is the connection between computers. www is inside the internet. Yes, okay, so websites, that is the World Wide Web. Okay, it's anything that uses HTTP or HTTPS, Hypertext Transfer Protocol. It's those pages with hyperlinks that you click on and they take you to other pages with hyperlinks, right? When you play a game on the internet, if you're playing a game over Xbox Live or PlayStation Network or Steam or anything, excuse me, like that, you are not playing on the web, you are playing on the internet. The data packets that you send are not web packets. Okay, they are game data packets, but they are still sent across the same cables on the internet. Okay? Right. I want you to list, while I go and make myself a cup of coffee, I want you to list all of the different types of data that you can think of that would use the internet to travel. Okay, and I apologise for the state of my house behind me. In fact, no, I'm going to turn the camera off so you can't see. I'll be back in literally a minute. Okay, so list all of those different types of data that are travelling across the internet. Okay, right, let's have a look and see what you guys have written. So, blah, 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 blah. Hyperlinks. A hyperlink is that's a section of a web page, okay? Did I spill something there? Yeah, I did. I spilt, my espresso machine had some old coffee in it and I dropped it on the floor, so there you go. Messages, websites, downloads, yes. Uploads, right, you got to be more specific. Lots of data can be uploaded. So you would upload an email, you would upload data packets for a game, okay? An upload is not a data type in and of itself, okay? Text, video, and picture, yes, but again, those are file formats rather than protocols. Okay. Anyone going to add any? Rather asking about Kenko. Yeah, good. MP4 download. Again, these are file formats. These are not necessarily data types. Okay. Video cams. What else have we got here? .wtf. Okay, so do I have black coffee or white coffee? Well, as a vegan I cannot have milk, so I have my coffee black and bitter like my broken heart. Cheers, everybody. Download. Why is download specific but upload isn't? What do you mean? They are both specific. I'm not sure what you mean by that. Okay, so any data that you download will have it has a protocol associated with it. Any data you upload has a protocol associated with it. When you click on a link to visit a website, you will use the HTTP protocol to access that data. Okay, when you send an email, you will upload SMTP data to connect to your mail server. Does this make sense, right? And SMTP, that is a mail protocol. That is not web. Okay. That is not the web. Why do I make myself suffer? It's punishment for the wrongs that I did in my childhood. Did you say not necessarily? In what circumstances is it? Be more specific there, Harrison. I'm not sure what you're getting at here. Have I explained it in the little thing? Is MIME a protocol? Now this is interesting. MIME is a way of specifying different file types. Okay, so a MIME type is like when you click on a link in your browser, whatever it may be, and it's, let's say it's a link to an audio file, right? On your computer, you will have MIME types set up, which basically tell your operating system what the default program is to open those types of file. Okay, so that's what it is, right? What about POP? Yes, POP, that is Post Office Protocol. That is a data type. It's a mail data type. Okay. Does that make sense? I'm talking about data transmission types, and every single different type of data transmission has its own protocol assessed. You said those are file formats which are not necessarily file types. Yeah, I mean, okay, so let me give you an example. If I say BitTorrent, right, a BitTorrent file is it's a file, right? It's a file type, but BitTorrent is also a protocol. Okay, so if I use BitTorrent, right, I am using the BitTorrent protocol to transmit this data. Okay, is IMAP a data type? IMAP is a protocol. It's an email protocol. Why do we have male ones but no female? What? I'm confused about that now. Anyway, what on earth are you talking about? Are you talking about like people who are in the chat? Because we do have some women in the chat. I'm confused now. Anyway, I'm gonna move on, right? Protocols, right? So it's the sets of rules for explaining how to transmit different types of data across the network. Yeah, which means different types of data, i.e., things that are websites. That's one type of data. Email, that's another type of data. Streaming video like you are watching now, that is another type of data. Okay. I'm glad you and James get it. I don't get... Oh God, now I get it. Oh man, come on guys. Oh man. There used to be, actually, a boy band called Email, like spelt like that, Email. I think they lasted for one song before they faded into obscurity. Anyway, so emails and streamer classes data transfers. Yes, they are. They are not. No, let's set this straight, right? If you use something like Gmail, right, via a website, you are accessing a website which is then connecting to a mail server which uses mail protocols to transmit, email protocols to transmit, right? Okay, so the website section of it, that's just the interface through which you are connecting. Like YouTube, if you're accessing YouTube through the website rather than an app on your phone or tablet, right? The video itself, that's not web data. That's video data. That's streaming video data. But the website provides the interface through which you can access that other type of data. If that makes sense. Mark was here. I think he had to step out for whatever reason. But I mean, he can catch up at some point. You know, it's going to be available, so you can do some last minute revision. Right, where are we up to? We've been streaming for an hour. Let's keep going. Right. Okay. So, what protocols do you know? You don't need to, you know, it's not a requirement that you know tons of different protocols. What's happened there? I'm gonna, oh look, I stretched my face out. Let's just go back to normal. There we go. Right. So your sister keeps watching over you. What, watching over you, like keeping you safe, or watching the screen over your shoulder? If hi Emily. Anyway, so right, okay, so protocols that you need to know. Obviously you need to know HTTP, you need to know HTTPS. It's Hypertext Transfer Protocol, which is used for... What's HTTP used for? What type of data transmission is HTTP used for? Well, one of these is used for... Yeah, website packets. HTTP is websites. Okay, HTTPS, as you pointed out, Callum, is encrypted websites, encrypted website data. So just remember, if there is not an S in the corner, your website is not secure. Okay. Other things that you need to know. FTP. Do we know what FTP stands for? Sometimes pronounced file transfer protocol. Now, back before the World Wide Web, when we connected to the internet, we usually accessed an FTP server. And if you imagine, you know, when you access your file browser on your computer and you've got like a list of folders and you can like copy files, that's what FTP basically is. So back in the 90s, before the World Wide Web was a thing, we would connect to the internet and then we just have like a list of files, and there'd be the first file that you downloaded would always be it would be called index.txt, which would contain a list of all of the files. Okay, not quite back in the printing industry, but yeah, and that's historically why the default file name for websites is index.html. There you go. So yeah, FTP, and there's also SFTP, which you can probably guess what that is. What's the S stand for? Yeah, secure. So again, it's encrypted. Now, just because we mostly use the World Wide Web when we're distributing data on the internet these days, don't think that FTP is no longer valid, because companies that need to transfer big files, often across a WAN, will use FTP. And obviously, if it's like sensitive data, they're going to use SFTP to do that. Okay. So FTP is still a thing. Other things that you need to know: IMAP and POP and SMTP. These, all three of these, relate to what? In fact, this is the only protocol so far where the S does not stand for secure. Do we know what these stand for? IMAP and POP is email. What's SMTP? Yeah, all of them are mail. Okay, IMAP and POP. Right. Okay, so IMAP and POP are generally used for the receiving of email, whereas SMTP is used for the sending of email. Okay, so yeah, you've got simple mail transfer protocol. You've got internet message application protocol, I believe, or is it access protocol? You guys can tell me that. And POP is post office protocol. As a general rule, pretty much no one uses POP anymore. Some people might if they're trapped in 1999. Generally speaking, we'd use IMAP because it allows you to remotely access your mails on the server, and when you delete them from your mail client, it will delete them from the server as well, which is just nice. Okay, it's nice synchronized. So yeah, I don't think you need to know any other ones except maybe Bittorrent. Okay. Bittorrent is kind of similar to FTP, but instead of a direct download, it uses a peer-to-peer network, which we will have a look at in about 15-20 minutes if we're still going. Yeah. Okay. Right. So, James, you were the main one that was screaming about protocols. Are you feeling more secure, about protocols? Are you good for that? All computer scientists are hilarious. It's a proven fact. Yeah. Okay. Cool. Right. So I think Tom was interested in what's it called? What are they called? These things. Topologies. That's right. Topologies. I've been awake too long. Yeah. We will look at moral, ethical, and legal concerns. Okay. So topologies. In the past, in previous years, you had to know about ring and bus networks. You no longer have to know about those things. Okay, so if you've got stuff about ring and bus networks, burn it. It's no longer necessary. Okay, you do not need that. Okay, it's just going to take up valuable memory address space in your heads. Okay, what you do need to know about is a star network and a mesh network and possibly a hybrid network. Okay, star network. Pretty much all of the networks that you will have encountered are probably star networks. So you know how star networks are connected. There's this little diagram here. Now, just because this, you got to remember, this is the logical layout. This is not the physical layout. If you imagine the computers that are connected together in C3, or indeed any computer room at school, there isn't just a machine in the middle and then all of these computers connected around in a circle, right? The thing in the corner of the room, you know, that big box on the wall with all the flashing lights, that's the main node switch. So all of the computers are in effect connected to that. That is the central hub, if you like, central in quote marks, because they are not actually in the middle. Okay, but if you were to sort of like lay them out so there was no wires crossing each other, it would kind of look like that. Okay, so every single machine is connected to this central hub. Okay, every single machine is connected to this central hub. The benefits of this are that when you send a message, okay, if I want to send a message from this where are we? This node here down to this node here, right? All it's going to do is it's going to send a message to the hub. The hub is then going to send it to here, right? I don't have to go around all of these other ones to get there first. Okay, so at most, any packet is only ever making 2 hops. Okay, it's the hop from the source node to the hub, and the hop from the hub to the target node. Okay, is this why every computer network went off when we had the power cut? Well, all of the power went off, but yeah, the reason you could no longer connect to the network, it's not because the hub was down, although it was. The reason you couldn't then verify yourself on the network is because the server was down, and we'll get onto that in just a sec. Okay. So if a big central hub had a virus, they would all have a virus. It's possible, but usually the hub itself will not be a machine in the same way, you know, like a desktop machine in the same way that the other ones are. It's usually a switch, like a little, in fact, let's see if I can find a network switch. Let's find a picture of a network switch here. It looks like this. Okay, there's a network switch. So you'd plug in all of your individual computers into these things. That's usually what it looks like, rather than an actual machine. Okay, now these switches do run their own operating systems. Okay, but they're usually pretty secure. They're usually fairly robust. Okay, they're examples of embedded systems. In fact, okay, we know embedded systems, right? Okay, so what do we got down here? Advantages of a star network. Very fast. And the reason it's very fast is because the traffic doesn't have to go very far. It reduces the amount of collisions on the network, which means that data is transmitted faster and there's less chance of your data getting lost. It's easy to add new nodes. Okay, all you have to do is, if you've got space on your hub, you plug in another computer. Boom, you're done. Easy installation and configuration. I mean, it's so simple to put together. Right? There's only one way the cables can go in, and they're usually just like plug and play, right? It's easy to detect faults because the bit that's not working, everything else will be working. So it's like, oh, there's a fault on the network. Okay, cool. The fault's on this machine, therefore I know it's either this machine or it's the cable between this machine and the hub. Okay, sorted. I will cover the difference between a switch and a hub in just a sec. Okay, failure of a single node will not bring down the whole network. In older network layouts like the bus and the ring, if one of the nodes went down, the entire network would be offline. But this node could die, and everything else would quite happily carry on. Okay. The disadvantages: failure of the central hub will bring down the whole network. So there's a single point of failure. Okay, so if that thing dies, you know, the whole network dies. But usually we'd have like what's called a failover switch. So if the main switch fails, the network gets rerouted through the failover. Okay. Star networks, they used to be super expensive. They're still more expensive than something like a bus network, but really they're cheap as chips. And a switch will cost you maybe 20 quid, and then you know, you're looking at you know, £5 or £10 for the cabling. You know, it's nothing really. But they can be expensive if you've got lots of nodes, because you're going to have a fair amount of cables. Okay. Thanks for your time, Tom. Hope this is useful. It will remain up on the tubes, so you can check it out. Right. You need a lot of cables for a star network. Okay, that's just the thing. I mean, the advantages far outweigh the disadvantages. Now, Blessed asked about what's the switch and hub thing. Okay, so there's two different central points that you can have. A hub sends data out to all nodes. Okay, a switch only sends data to the target node. Okay, that is the difference. Okay, if if this node wants to send a message to this node, if I was using a hub here, the message would get sent to the hub, and the hub would send it out to every single node and say, yo, this is for this node here, so don't open it, okay? Whereas a switch, you'd send the message to this node, and the switch would say, right, I'm just sending it to that one, okay? So what happens to the internet in the case of net neutrality? So net neutrality, that's something that applies to the United States, not necessarily anywhere else in the world, right? The concept of net neutrality is that businesses cannot charge extra money, or they cannot change the speed of transfer, the speed of transfer for like different types of data. But bear in mind, it is a US law, it's not over here. So, and just to remind you as well, the net neutrality is a good thing. The removal of net neutrality, that's the bad thing. Okay. Anyway, moving on, a mesh network. Mesh networks are even easier to set up than star networks, okay? Because all you need to do is plug different networks into each other. They are usually used, like if you set up like wireless access points and stuff like that, okay? Oh, don't get me started on Article 13. We can discuss that till the cows come home, but we're not. That's not what we're here for right now, okay? Mesh networks, they are reliable, they are self-healing, and by self-healing I do not mean that the wires magically mend themselves when they break. What I mean is, if something like, if say for instance this cable broke, right, I would still be able to send a message from this machine to this machine. It's just that the packets would have to go around this route instead. Okay, so self-healing means it will reroute traffic where it needs to go. Okay. If you don't use any wires, mesh networks are cheap as chips. If you use wires, they can be expensive, especially if you use a fully connected mesh network, because then every node is connected to every other node. Okay. Regarding Article 13, there's more to it than just banning memes. I mean, I disagree with it on copyright grounds, because copyright is a fundamentally it's an old thing which really desperately needs revising, but we're going to have a look at that in a sec when we look at legal, cultural and ethical issues. Okay. Explain usually secure. I mean, it's usually secure. Nothing's ever totally secure. Okay, you can't say right, okay, this network is secure, you know, because nothing's ever secure. As a general rule, if it's set up and managed properly, it will be secure. That's it. So when I say usually secure, I mean like if it's done properly, it's secure. Does that make sense? HTTPS will encrypt your data when you send it across. And again, HTTPS usually secure, but there are some nefarious companies that will use HTTPS, but they will not be properly certified. So again, yeah. And that's it on network topologies. So usually star networks are used in businesses and organizations where they're establishing a permanent network, and they're usually best suited to client-server networks, whereas a mesh network is like your home network is probably a mesh network. Although I don't know, if you've got a central router, it's probably more likely to be a star network. But if you're setting up like ad hoc networks, peer-to-peer networks are usually mesh networks. Okay. Just a quick note on hybrid networks. I don't know how likely this is to crop up. Probably not likely at all, if I'm honest. But if you've got more than one topology on a network, it is a hybrid. Okay. Literally every day I wear a tie. I don't have a bow tie though. Anyway, so in this example here, I've got 4 different star networks, and they are each connected to each other on a bus network. Okay, each section of the network is subject to its own advantages and disadvantages based on the topology that it uses. Okay, so if this node if this node here on this star network fails, right? everything will still be able to communicate with each other. That's all fine. If this switch here fails, obviously all of this star network will be wiped out. Everything else will still work fine, and they'll be able to communicate with each other. If there's a break in the bus network here, it doesn't matter that these two networks on this side will be able to communicate in theory. A break in a bus network means the entire network goes down. So the individual stars will be able to communicate with each other, but they won't be able to communicate across the network like that. Okay. You're still getting lag. Let me just double check something. I'm just going to... I'll be back in a sec. I just want to check something out. Okay. I mean, my stats say that the stream is still nice and healthy. If you're getting lag spikes, either drop the resolution down, or like ask everyone else in your family to stop using the internet or something. I don't know. Get selfish net. Yes, selfish net. I don't know. Maybe you guys are victims of a removal of net neutrality on your home networks. Who knows? Right, where am I going now? Pa-bang! Nope, that is the Google Classroom. We're not interested in that right now. Are we interested in that? No, we were interested in networks. Boom. Okay, so yeah, so here we go. Star network, mesh networks, hybrid networks. We've covered all of those. Are you happy now with network topologies? EU is not necessarily bad. The EU have done a lot of very good stuff, and things like human rights. I'm pretty much in favour of human rights. I think that's a good thing. I'm very much in favour of freedom of movement. I want to be able to go to whatever country I want, but none of that's got anything to do with computer science at the moment. So let's continue. What's on the mug? Are you familiar with the TV show Lost? It's a Dharma Initiative mug, and it's got my name on it and my employee number. It was a birthday present a few years ago, so pretty cool, right? Yeah. So anyway, I'm not going to cover the TCP/IP layer model because we did that extensively in a lesson. I will put this up here and then skip through there, and then when you go back you can always sort of like pause it at various points and have a look at that. Okay, so there we go. Right, this is the bit where we kind of got up to this and then I didn't have time to go through it, so I've got two different images here. What do these two different images show? Just have a look at those two different images. If you can't see what this is, that's a picture of Joseph Stalin, and here down here we've got a women's rights march for equality. Okay, so yes, communism and feminism, but what's specifically about them, and why on earth have I bothered putting them in a presentation on networks? And to address your point, Blessed, yes, we will have a look at logic gates. Okay, so we can do that. So any thoughts on why I might have put these? Hey, boom, central control. Which one of these refers to central control? Yes. So Joseph Stalin, leader of the Well, I'm not going to call it communism because it was totalitarianism. They are different ideologies. But generally speaking, we had everyone is created equal except for Joseph Stalin, who was created more equal than the rest. And so he is the guy in charge. He's the boss, right? One person controlling all of these people. Whereas with the women's rights here, they are fighting for equality. Okay, they want everyone to be equal. Okay, and in certain non-hierarchical anarchist systems, there are no people above other people, and so on and so forth. Okay, so what's that got to do with networking? Client-server networks, i.e., the centralized control. Client-server networks, the totalitarianism of computer networks, if you like. Okay. One central server which controls user access, file access, and shared resources. Okay, this is the reason why after the power came back on, none of you guys could log on. Okay, the switches were up and running. I could see the lights flashing on the switches. The problem was because the central server was not yet online, it couldn't verify your login details. Okay, so what the central server does is when you type in your username and password, the central server says, right, does this user exist? Yes, they do. Okay, cool. So have they got their password correct? Oh, yes, they have. I will let them in. And then it will say, what type of user is this? Okay, when I log on, it says, oh, it's a staff user. So he has access to XYZ. Okay, when you guys log in, it says, it's a student user. Therefore, you don't have access to the other stuff. Okay? Passwords don't work like that. I mean, I'm simplifying a bit, but you know what I mean. Okay. Generally, well, technically what it would do is it would hash the password, and then it would compare the hash to the stored hashes that are on the system. So yes, you are correct, but I'm simplifying. All the other machines are known as clients. So this central machine, okay, it's responsible for handling like shared resources. You know when you store stuff in your user areas, right, on the U drive, they are stored on that specific server. Okay, there's a massive rack of hard disks in a RAID array, and all of the data is stored there. Okay, so it's that central server. If that blows up, all of your files get wiped, right? But that's why we sort of like back it up every day or whatever. Okay. Quantum computers could decrypt your password in seconds. Well, okay. So just be careful what you read about quantum computers. Potentially yes, but yeah. Well, yeah. So there's a lot of stuff out there about quantum computers. Not all of it 100% accurate. In the same way that there's a lot of stuff out there about essential oils, none of which is accurate. So it's possible to set up multiple access levels or user groups. Like I mentioned, if I say you are a member of the student group, then you have what's called a group policy applied to you, which allows you to access XYZ. If you are part of the staff group, you have a separate user group policy applied to you, which allows you to access different things. The downside of client-server networks, generally they're very good at making sure that the right people are able to access the right places, right? They do require dedicated maintenance, and you usually have to employ admin staff, if only just a single server admin, to make sure that to make sure that it's all under control. Okay, so it can be expensive that way. The other type of network, peer-to-peer networks. This is where all machines are considered equal. All machines can share their hardware or files. Like I could have a printer connected to my machine and I could share it up and say, yo, anyone can print to this printer. Okay, I could share up the files that are stored on my computer and anyone could access those. Okay, it's the problem with peer-to-peer networks. They're very, very quick to set up. It's difficult to set different access levels, or sometimes impossible. either everybody has access or nobody has access. The other downside with peer-to-peer networks, because there isn't a central server moderating how fast everything's being transferred, they can get very slow if there's lots and lots of machines connected. But the benefits, they are super duper cheap to set up. Now, peer-to-peer networking is what Bittorrent uses. If you imagine the difference between Ftp and Bittorrent as the difference between client-server networks and peer-to-peer networks, right? Ftp, you have a file on a server. Let's say, here's my file on my server, and I want to get it. I get that whole file, and I download it all at once, and it's a direct route from that server to my machine, and I have to get all that file in one go, and then it's done, right? With Bittorrent, you've got to imagine that that file, it can be downloaded. It's not downloaded from a central place. It's downloaded from anyone that has that file. Okay, and the way that the protocol works, it says, right, look at everyone that's connected to the network at the moment. How many of them have this file? Okay, once, you know, let's look at all these. Right, so I'll grab this part of the file from this person, I'll grab this part of the file from this person, I'll grab this part of the file from this person, and so you're pulling in different bits of the files from all over the place. Okay, usually slow to get going, but they can be pretty fast. The downside of BitTorrent transfers is if the person that you're getting the file from goes offline, you can no longer get the file. Okay, which is obviously drag, right? Generally speaking, the reason we use BitTorrent, there's big companies will use BitTorrent as well. Blizzard, for instance, use BitTorrent when streaming World of Warcraft patches. I know Codemasters used BitTorrent when we were doing the Lord of the Rings Online updates, because it cost the company a fortune to have the bandwidth to send out massive files on a one-to-one basis. If you imagine it, if it costs a penny to send that big file once, and there's millions of people getting that one file from you, A, it's going to put a massive strain on your network, and B, it's going to cost you a fortune. But if you share that file out to a few people, and then you say, right, it's out in the wild now, just grab that file from whoever's got it, okay, you end up saving money on bandwidth as a company. Okay, and that's pretty much everything about networks. I don't think I need to do anything else on networks. We've pretty much covered all of the bases. Okay, so the next thing that you guys mentioned was legal, ethical, and cultural. Ethical, legal, cultural, and environmental concerns. Is that right? Should we have a quick look at some of those things? I'll scroll down to the thing, and we'll have a look at the stuff that you need to know about. Okay, so this is the stuff that you need to know about. Learners should have studied the following: how to investigate and discuss computer science technology while considering ethical issues, legal issues, cultural issues, environmental issues, and privacy issues. Okay, so I've been over this in class. Remember, ethical issues, anything that infringes on the rights of other people generally is considered unethical. Anything that infringes on the law of the land is not legal. Cultural issues, obviously, this is something that is it's not just necessarily about different cultures in different countries, but it might be different religious cultural differences and things like that as well. Okay, how should we structure our 6 markers? So in the exam, the sorts of questions that you will get, they will say things like people love to buy new technology. This has an effect on the environment, and blah 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 blah. Discuss the effects, discuss the ethical, legal, and cultural issues and environmental issues that surround the advancement of technology, blah, 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 blah. You may wish to consider blah, blah, blah. And they will usually list 4 different points, okay? So this is how I would structure your 6 markers, right? First of all, do not start off with, there are many ethical, legal and cultural issues surrounding the use of computer science. Yes, we know. That's why we're asking the question. Don't bother with that. It's a waste of time. Okay? So just launch into it and say, some of the reasons why people might find these things problematic are blah blah blah, right? And if you tackle each of those bullet points that they give you in turn, right, explain some of the effects of ethical issues on stakeholders. Explain some of the effects of these ethical issues on the manufacturers of the hardware or whatever it is that they mention. Okay, address them in turn, and then at the end have a summary which sort of like ties them all together. Okay, so you have a sentence which is sort of like an introduction of sorts, and then you have a couple of sentences addressing each of the bullet points that they give you, and then at the end you have a summary which sort of like, you know, in conclusion, yada yada yada. Okay, so it's offensive. What's offensive? Okay, so let's have a look at this. Privacy issues. We're all clear on privacy issues and how everyone has the right to a life free from the prying eyes of others, right? So you know, there's that. How key stakeholders are affected by technologies, environmental impact of computer science, cultural implications of computer science, open source versus proprietary software, and legislation relevant to computer science. So a lot of this stuff is fluffy enough that you can kind of make stuff up. I mean, you guys are 15 going on 16 years old. I think at this point in your life you probably know the difference between right and wrong. Okay, you know when things are a nice thing to happen to someone, and you know when things are a bad thing to happen to someone, right? So you can kind of, if you're ever stuck, you can sort of think, is this something that I would like to happen to me? So environmental issues. Obviously, the manufacture of electronics kicks out a whole bunch of horrible waste products. Now, often it's third world countries that are rich in the resources that we need over here in the West for our technology. And it's not really right that we exploit those countries for their resources and they get a bum deal out of it, and then we end up dumping toxic waste in their environment. You know, that's bad. And so one of the ways that we can offset that is obviously by recycling and reusing things. Okay, and also making things that are designed to last rather than making things that are designed to last a year and then get thrown away. I've never really understood this constant need to continually upgrade your phone, especially an iPhone. It makes no sense because it seems that new iterations of the iPhone get progressively worse with the removal of headphone sockets and the removal of NFC readers and things like that. It's just a nonsense. So that's something to bear in mind. As we speak, right? The stereo amplifier that I have connected to my computer, I bought for 250 quid in 1998, right? And I see no need to replace it because it's still damn good. Okay. The NFC reader was not in the iPhone 6 or 7, I believe. They reintroduced it. So yeah, and always functionality over appearance. Okay. So anyway, where did we get to? Let's talk about the difference between open source and proprietary software, right? And if you just bear with me a sec, I've got a quick presentation that might help us out. So just bear with. I will find said presentation, or excuse me, presentation, if you're American, which we're not, so it doesn't matter. What is happening here? What's happening? Open source. I spelled source wrong. Commenting out that Apple hate. I don't hate Apple. I'm just find it bizarre. Right, what have we got here? Are you ready? Ba-boom! Proprietary and open source software. Here's one I made earlier. I'm not going to go through all of this, right? But this was the example that I gave. You know that game you play where you write a sentence and then you fold it over, and then you pass it to the next person and they write a sentence and then they fold it over, and then at the end you've got some crazy little sentence like that makes little or no sense, right? You played that game before? Or am I jumping to conclusions? No, you never played that. Okay, so I'm going to totally ignore that, right? Proprietary software. Proprietary software is software which is made by one individual or company. Okay, I've got the Apple logo up there, right? But you know, any company that makes software, it might be Microsoft, it might be Adobe, it might be I mean, some Google makes some proprietary software as well. Okay, it's it is what it is, right? Okay. When you get proprietary software, you cannot make changes to that software because you get the final product. You don't get access to the source code, so you can't make any changes. Okay. Now, proprietary software is great if you want to go and buy something and you know that the software does the thing that you want to do, right? However, if you want to actually change your software because it doesn't do all of the things that you want to do, you're generally on your own, right? If the software doesn't work with your hardware, then you're going to have to wait for that company to make an update, and you've got no control over it. And no, you are not allowed to make changes to it privately, because in order to do that, what you would have to do is you'd have to decompile the program into source code, and that's reverse engineering, which would be contravention of the Copyrights, Designs and Patents Act. So you are not allowed to do that. Even if you've bought the software, you have no right to do that with proprietary software. Okay. Open source software, on the other hand, this is where software is available, and you can download the software pre-built if you want to and just use it as it is, but you can also get access to the source code, so you can make changes yourself, so you can make it do what you want to do. Linux is the prime example of open source software. It's a full operating system. My operating system is a custom operating system which is built on Linux. Okay, so I've edited the source code, etc., etc. Apache is the web server that runs most of the World Wide Web. Android is an example of an open source operating system, and Firefox, which is my web browser of choice. So Callum, your phone runs on Android, right? The interface is EMUI, or however you pronounce that, because that's Huawei's interface to the Android operating system, right? So in terms of open source, right? Open source, is it easier to hack? Well, it's easy to think, well, if I can see the source code, then that's going to make it easier to hack. But because literally anyone can see the source code, it means that anyone can modify the source code and anyone can fix those security holes, right? So generally, if there's a security flaw in an open source product, it will be patched out within days, sometimes hours. I think the record for a security hole being fixed was something like 30 seconds. Once it had gone live, someone noticed that there was a security flaw in the code, they patched it out, and then they re-released a new version within seconds. Okay, so if you think, oh no, if you can view the source code, that makes it easier to hack. No, actually, it makes it more secure because there's more people that are able to fix those problems with it. On the flip side, if you take proprietary software, if a security flaw is found, it might be months before anyone even notices outside of the people that originally discovered it. Okay, it might be years before that security flaw is patched out by the company that makes it, or never. Okay, so generally speaking, open source software, as long as it's regularly maintained, will be more secure than proprietary software. That's why the Linux operating system and other open source operating systems like BSD are far more secure than Microsoft Windows, because everyone can view the source code, and so everyone is working to fix those holes. So generally speaking, open source software is more secure than proprietary software. Okay. Now, the other great thing about open source software is you can download it, you can make your own changes, and then you can distribute those changes so that other people can use the changes that you have made. Okay, so as an example, I've got a very old Microsoft joystick. If I just move my chair back, hang on, I'll grab my camera. Is this going to work? You can see, there we go. This is my very old Microsoft joystick, which is at the moment it's attached to my chair. When I play Elite Dangerous, I have my joystick attached to this side of the chair, and over there I have the throttle unit attached to that side of the chair. Okay, so obviously I'm running Linux, and Microsoft made that joystick way back in the 90s. Okay, they released proprietary drivers for Windows, but they never released any drivers for Linux for obvious reasons. Now, I did find some drivers which were for a different joystick, so based on that, I wrote my own drivers for this particular combination of the Microsoft Force Feedback 2 and the CH Pro throttle unit. And once I'd written that, I distributed it on the internet so that other people could use it. Okay, so I mean, it's a really specific combination of hardware, but I know there was at least one other person that had it, and there was another person who had not quite the same stick but a similar setup. Right now, I distributed that that code which I'd modified. It was based on some open source drivers, and I modified it so they work for my hardware, and then I distribute it again. When you distribute open source software that you have changed, you have to allow other people to make changes to your changes as well. Therefore, when I distributed those drivers again, the person who had the CH Pro throttle unit, and I think it was a Logitech Wingman joystick, they were able to take my changes, put their own changes on it, and get it working for their system as well. Okay, so the idea is that, yeah, you can make any changes you want to, as long as when you share it again, you allow other people to make those make changes and then continually pass it on. Okay. Why do you think companies might prefer to... there's a question that you can answer. Why do you think companies might prefer to make proprietary software rather than open source software? Yeah, pretty much to control the money. Now, just because your software is open source, that doesn't mean that it has to be free of charge. Usually it is, but it doesn't have to be. Companies don't like to, I mean, if they have built their business on this software, they see it as company secrets, and so they don't want people sort of taking that code and then using it, you know, and copying it. And so yeah, there's a number of different reasons. They want to make sure that they can still make money off of it. They want to make sure that other people don't copy their code and use it in other things, right? But again, it's not because of hackers. Right, you've got to remember, because open source software is generally more secure than proprietary software. Right, if a company used open source software, generally speaking, their stuff would be way more secure. Okay, that's why, like I said, Linux is more secure than Windows, because like these things are patched out. It's generally because they don't want what they see as company secrets being leaked. Okay. Here's a question. Can you think of any drawbacks of open source software? drawbacks of open source software. It's open to hackers, yes, but as I have already mentioned 2 or 3 times before, why is that not necessarily a problem? Yeah, it's easily repaired. People will patch it out. Now, I see what you're saying there. Someone could make a damaging version. Now, the thing to remember about most open source projects, right? It's not just a case of here's the code, go and distribute it, right? You still download it from a centralized location. There is central control over what patches make it into the version that gets released and not, right? So if someone does inject a virus into some of the source code, then the project manager, for there are still project managers, the project manager is going to look at it and say, nope, that's not going in there. Okay, so you've got to get this idea out of your heads that hacking and viruses and malware is a problem with open source software, because it really isn't. Okay, that's not a problem. Yeah. I mean, the drawbacks of open source software, a lot of the time the people working on the projects are volunteers. They're not paid by a company, right? And they're giving up their time to work on these projects. And sometimes life gets in the way of some of the things that we do as hobbies, right? So if you're there thinking, right, I'm going to work on this section of Firefox and I'm going to add this new feature to Firefox, and you might spend months or years working on that, and then I don't know, your dad dies or something, and you're like, well, I can't face doing anything right now, you know. Then any updates that you are making sort of get put on hold, okay? And people can't say, oh, why aren't you coding, you know, because you're not employed by anyone, okay? So and again, open source software is not low quality software, okay? I mean, Android is one of the most popular operating systems in the world. Do you think that's low quality? Linux is one of the most popular non-Windows operating systems in the world. That is not a low quality piece of software. Okay, think about Firefox, Google Chrome. Okay, these are all open source pieces of software. They are not low quality. You know, they are better than their proprietary competitors. Firefox and Chrome are way better than Microsoft Edge. You know, and they're open source. So there seems to be this feeling that if you're getting something for free, it must be rubbish. That's totally not true. You know, it's in fact the opposite is usually true. I often think if I'm paying for something, I'm probably getting ripped off. You know, that's how I look at it. Okay, OS X it's not based off Linux. It's a Unix derivative. Now Unix is not the same as Linux. In fact, Linux is short for Linux is not Unix. So yeah, Unix and Linux are very similar looking operating systems, but under the hood they're different. But yeah, OS X was based off BSD, I think, which is a Unix variant. Okay, which again is based on open source stuff. Okay, now Apple have layered their own proprietary stuff on top of that, but at its core, it's a very secure system, which is based on open source principles. Okay, so the main drawbacks of open source software is there's no guarantee that a project is always going to be updated. Sometimes projects get abandoned before they're properly finished. Okay, yeah, I mean that's really all there is. I mean, there's sometimes that you might think, well, I need some open source software to do this particular thing, and no one's created an open source project that covers that. Okay, but again, there's nothing stopping you creating your own. Okay, so there you go. Okay, so generally speaking, there are benefits to proprietary software. The other drawback of open source is that a lot of the time the documentation is generally poor. Not always, but quite frequently, programmers tend not to enjoy writing manuals because they're like, well, I've written this program, I know how it works, you know. yeah, generally speaking, documentation can be difficult, and also if you buy a product from a company, then usually they will offer some sort of technical support package. So if you get stuck, you can phone them up and you can say, right, I'm trying to do this and it's not working. How do I fix it? And they will say. But with open source, you're relying on like the goodwill of the community to help you out. Marketing is bad. Marketing's not really an issue because these things are not being sold, so they don't need to be marketed. You know, it's a case of it's there, and you can download it if you want, but they're not trying to sell it to you. You know, it's they don't need marketing. Hello, Arctorpus the Great, whoever you may be. We've been online for a couple of hours and we're kind of drawing to a close. Generally speaking, if I see an advert for something, I will not buy that product. I can't stand advertising. Good. So that's the difference between what's it called, proprietary and open source software. There. Let's just go to the GCSE computer science folder. Let's just open up those specs. We might be able to briefly go over what's it called, thingies, systems architecture, but I have covered that fairly extensively in the lesson, so you know, I'll quickly skip over that. What about iOS with Safari? No, so Safari is a proprietary web browser. It's made by Apple, and you are not able to edit the source code. Where's this spec? Right, okay, so let's just have a quick look here. The acts of law that you need to know about: the Data Protection Act, which I've gone over, the Computer Misuse Act. So data protection is all about keeping your, if you are saving people's data, then you know, you need to make sure that you're keeping it secure. You're not using it for any purpose that you didn't originally gather it for. You're not requesting excessive data, etc., etc. Computer Misuse Act, that is designed to prevent people from accessing computer systems, either with an intent to damage the contents. Can I play you some guitar? Maybe. What else? The Copyright Designs and Patents Act. Okay, Copyright Designs and Patents Act is obviously when you create a creative work, you have... Why is that on there? Oh, no, I know what's happened. Just bear with me a second. That's the one that I want to go to. Okay. Nope, I've messed it up again. No. There we go. Go to OK. Good. Yeah. So obviously that's misused, and our data is sold to the government. The data is not sold to the government. There are strict rules that govern what data can be sold and to whom. And if the government wants to collect data, they will have their own methods of collecting data. They will not sell the data to the government. I'm not sure where you're getting your information from there, but it's probably wrong. What about China's social credit system? That's got nothing to do with what we're doing right now. Okay, so Computer Misuse Act is to prevent unauthorized access to a computer system. Copyright Designs and Patents Act, when you create something, you have the right to say how that work is used. Okay, so you don't have to apply for copyright. Okay, when you create something, you hold the copyright to that thing. Okay, and you have the control over how it is used, and that copyright extends from the moment the thing is created up to 70 years after your death. Okay, now copyright is not a guarantee that you will make money from a thing. It's just there to make sure that you can say, right, for instance, if someone took one of my songs and they used it in a McDonald's advert, I could say to McDonald's, "Oi, what you doing?" Okay, So will there be another live stream before paper 2? You mean on Sunday night? Maybe I'll do one on Sunday night. Let me just... do you guys know about Creative Commons licensing? Just say yes or no. Do you know about Creative Commons licensing? No. No. No for. Yes. Yes. No. Okay. Right. Creative Commons licensing is kind of similar to copyright. But it's a little bit more I don't know, in line with the way the world works these days. Okay, so the whole point of Creative Commons is it's sort of yeah, I've licensed this video as Creative Commons. Basically, it's not the same as copyright, but it's similar. Okay, and there are a number of different things that you can say that you will allow people to do or not to do. Okay, so if you license something under Creative Commons, there are four. In fact, let me find the there's an icon that I can walk you through. Creative Commons icons, images. So here we go. Here we go. That's the thing I'm looking for. Okay, so view the file. There we go. So we have got this stuff here. Okay, there are four different aspects of Creative Commons. Right? Attribution means you must always credit me. Okay, so the very most basic Creative Commons licensing agreement is if you create something and you license it under Creative Commons, people are free to reuse that as long as they say this was originally created by this person. Okay, and that's fair enough, right? The second thing is non-commercial. You can flag your creation as you're able to reuse it, but not for commercial purposes. Okay, so if this icon appears in there, you can reuse that thing, but you can't make any money off of it. Okay, so for instance, if I was doing a live stream like this, I could use a Creative Commons licensed work. I'm not making any money off of it, and I would not be able to make any money off of it even if my stream was super popular and I was getting loads of ad revenue, which I would never do anyway because it disgusts me. Okay, now this next one, non-derivatives. Remember what I said earlier about open source software? You can make any changes that you want to it. With Creative Commons, generally speaking, if you don't see this icon, it means you can take that work and you can change it. You can remix it if it's sound. You can add things to it if it's an image and stuff like that. Okay. If you see this icon though, non-derivatives, it means you can do what you want with it, but you're not allowed to make any changes. Your version must equal mine. Okay. And then finally, the share alike. Okay. If I allow you to change it, repeat my Creative Commons license. So if you do make any changes, when you share it, you have to allow other people to make changes as well, right? And if it's licensed under non-commercial and you make changes and you share it, you have to also flag it as non-commercial, okay? So share alike means when you share it, it's got to follow all the same rules as the original creator. Okay, and if that you would is talking about me accepting ad revenue, I guarantee you, and I'm looking directly at the camera, I guarantee you I would not accept any ad revenue. I'm not interested in making money. I do this because it's the right thing to do, and I give my knowledge away for free because that's who I am, and I would never make money from it. So that's Creative Commons. There may be a question on the paper 1. It was not going to come up on paper 2, but if there's a question about Creative Commons, it'll be on paper 1. It might ask you what Creative Commons licensing is. As long as you can remember those 4 things, it might be worth like getting a screenshot. Okay, you are going to be able to revise from that. So remember, Creative Commons, first of all, this is compulsory if you license something under Creative Commons. anyone that's reusing it has to say that you are the original creator. If you flag it as non-commercial, then people that reuse it are not allowed to make any money off of it. If you flag it as non-derivatives, people are not allowed to make any changes. And if you flag it as share alike, it means that if people do anything with it, they have to share it with the same rules that you specified. Okay, the album that I released with my band was all licensed under Creative Commons, so you know, because that's it follows our belief system that this is. I think this is more relevant to the way that we live today than copyright law, which was originally invented to encourage competition, but is now sort of been hijacked by big media companies in order to ensure profits. So it's being used really for the wrong purpose, and I think Creative Commons is a big step forward. You can find Creative Commons licensed works. For example, this is a book that I might have mentioned before. There is a book by a man called Cory Doctorow called Little Brother. You will notice you can download it for free. Okay, this is a book. It's focusing around a bunch of students who are pretty much your age. Okay, so you probably relate to there. It is been released under Creative Commons. It's about them sort of protecting their identity and their information. It's kind of like a modern day 1984 with teenage protagonists. I think it's an amazing book, and I think you guys should read it. And you know what? You can get it for free, so what's stopping you? And there was a sequel called Homeland, which is also available for free. Okay, if you go to this website here, I will post it down in here. Boom, if you go to that website, https, the S stands for secure, craphound.com/littlebrother/download, or you can just search for Little Brother, and you should be able to find that. There's a whole bunch of other stuff that Cory Doctorow has written. The man is a legend, his books are wonderful, and I highly, highly recommend. In fact, down here, look, amazing book. I just found it and downloaded, read the first 4 chapters. So it's available in a variety of different formats as well. Again, this is the beauty of Creative Commons, because Cory Doctorow wrote the book and he published it, and then you can see there's thanks to all of these people. These are all the people that have taken the original version and they have converted it to these different formats, and then they've been made available on here. So even I mean, there's some really weird things down here. A Unix help file format, which is just bizarre. If you've got a Texas Instrument calculator, you can load the book onto your calculator and read it there. So I mean, this is the great thing about Creative Commons works. There's also a website called jamendo.com, www.jamendo.com. Jamendo is a music website. It's kind of similar to Spotify, I guess, right? And it's all Creative Commons licensed music, okay? So you're not going to find any songs by artists that you necessarily know, right? But you can find some really great stuff on here. Okay, remember, if you like music, that's because you like it. Don't like music because someone on the radio tells you you should like it. And don't think, I don't like this because I haven't heard it yet or no one's told me about it, right? Just, I'd recommend going on this and search for something that you might like. Let's see. Let's search for some rock. What have we got here? Oh, look, there's even rock radio. Let's play some rock radio. Let's see what's... Don't know who this is. There we go. I'm going to pause that now. So there is no chance of getting a copyright claim on that because you know what? It's not copyrighted. It's Creative Commons. I can reuse that. Death metal. Should we search for some death metal? Death metal. Deathcore. TDP. These guys. Oh, look at this guy. Oh no, that's rap and hip hop. What the hell? I will admit the interface is not the greatest interface in the world. More communities. Oh, here we go. Maybe if I search for hashtag death metal. there's this metal. Ah! So yeah, there's some metal for you. So the thing is, like, leave it on throughout. There's not much of a rest of the stream. We've been streaming for nearly 2.5 hours, and you know what? I have not stopped all day. I've just realised there's some horrendous language in that list of music there. So check it out. If you, I often go on Jamendo to find sort of like instrumental EDM to listen to when I'm programming and stuff like that, and there's some cool stuff that you can find on there. So Creative Commons. Try it, you'll like it. We have pretty much covered it. I'm afraid, Callum, I really don't have time to cover the, what's it called, systems architecture, but if you just bear with me a second, I might be able to quickly run through some of those registers and whatnot. If I just go to... so the fetch, decode, execute cycle is probably there's embedded systems. What? What do we got here? No, that's the wrong stuff. Let's search for fetch, execute. That's a PowerPoint. What? Okay, let's open with Google Slides. Why are we quoting 1984 here? If people don't know what they say, then how can they mean what they say, what they mean, and neither does their votes. Yeah, I mean that really came out in Brexit, because there was lots of people voting to leave without actually knowing what that meant. A lot of them didn't even know what the EU was. Is now the right time to point out that George Orwell was a socialist? Just thought I'd add that. Anyway, how do you add a CC license to an image? Right, it's as simple as you go to the Creative Commons website. Right, all of the stuff that you could possibly need to know is on this this website. It's generally it's a case of slapping the right icons on the thing that you license. If you say this is licensed under Creative Commons, it is. You don't need to like apply anywhere. You know, you just say that this is what it is. Okay. Usually, what you would do though is you would register here. Okay. So if you click on Share Your Work here, there's look. It's use Creative Commons tools to help share your work. Our free, easy-to-use copyright license provide a simple, standardized way. So there's literally a step-by-step way of doing it on the website. Okay, so if we click here, you've got all of that information, which is I could spend all night going through that, but that's basically how you do it. Go to the Creative Commons website and click on Share Your Work and just follow that there. Okay. So fetch, execute cycle. I'm not going to do that. We've been through this in the lesson. I'm going to quickly go over it. I will remind you this is an abstraction. This is a model. This is not actually what the inside of your computer looks like. Okay, PC, MAR, MDR, CIR, and accumulator are all registers. A register is a tiny place in memory where you can store a certain amount of data. The PC is the program counter, which stores the current position in memory. The MAR is the memory address register, which stores the position in memory that we're about to look up. The MDR stands for memory data register, which is holds the data that has either been transferred from the memory store into the CPU or from the CPU into the memory store. Current instruction register stores the currently operating instruction. Accumulator is the mathsy register, where anything that we are adding to or subtracting from or doing any maths with gets stored. Okay. CU stands for control unit, which is the central unit which governs like the flow of data around the CPU and manages the fetch, decode, execute cycle. And ALU is the arithmetic logic unit, which is what done the maths. Okay, I will briefly, very briefly, because I'm aware it's like 9:20, and I literally got in from work, set up the stream, and you know, I haven't stopped all day. So very simple to remember. First of all, we do the fetch. So I wish I could. Oh, I can. Let's say when we first turn on the computer, we start off at position 0. Okay. When we fetch something, the value from the PC gets transferred to the MAR, copied to the MAR, I should say. Okay, that value stored in the MAR then tells us which address in memory to look up. So in this instance, it's LDA #007. That then gets transferred across the data bus into the MDR. Right, LDA #007. Okay, from the MDR it then gets copied to the CIR, current instruction register. So LDA #007. Okay, the final thing that happens when you do the fetch is we increment the program counter by 1. Okay, that's the end of the first fetch. We haven't decoded anything yet, we haven't executed anything, but we have fetched it. Okay, now when you are decoding, what that basically means is the CU looks at the current instruction and it says, what does this actually mean? Well, LDA means load data into the accumulator. So what the decode step does is it splits the instruction into the splits into the operation and the operand. Okay, so the operation is the thing that we are doing, and the operand is the thing we are doing it to. Now, in my made-up language over here, #007 means store the exact value 007 in the accumulator. So when we execute it, that's what goes in there. Okay, so now we start all over again. Okay, thanks for joining us, Harry. I will give you a house point. The PC is now at the position that we're going to look at next. So the value in the PC gets copied across into the MAR. Okay, and then we look up that address in memory. Well, at address 001, we have LDA 011. So we copy that into the MDR. Okay, LDA 001. Okay, that then gets copied into the current instruction register, like that. And then finally we increment the PC by 1, so that becomes 2. Okay, we then decode the instructions, so we split it up into the operation, which is LDA again, and the operand, which this time is 011, right? It's not #011, which means instead of storing this direct value, we are going to access the memory store. Okay, so we know that we are loading data into the accumulator. We need to know where to find that. This refers to a memory address, so we are going to copy that into our memory address register, because that is going to point at a location in memory. 011, we then look up address 011, that is 10. We fetch that data and we store it in the MDR. Okay, if you think I'm going fast, remember you can pause it afterwards. Okay, that data is then ready to be operated on. LDA means store it in the accumulator, load data into the accumulator, so that 10 replaces what we have got in the accumulator. There we go. Okay, and so on and so forth. Okay, so fetch, you copy the value in the PC into the MAR. You look up that location in memory. You copy the information that's stored at that location into the MDR. You then copy that into the CIR. You then increase the program counter. That's the end of the fetch. To decode it, you split the instruction into the operation and the operand. You work out what they are going to do, and then if necessary, you will have to plug values into the MAR to access the memory store, copy data across, etc., etc. Okay, you will not be asked to you don't need to know any of the programming. You just need to know the steps of the fetch, decode, execute. Okay, so PC gets copied to MAR. The address in the MAR is looked up in the memory store. The data stored at that address is copied into the MDR. The contents of the MDR is copied to the CIR. The PC is updated. End of the fetch. To decode, the instruction is split into operation and operand. That's the end of the decode. Execute, the instruction is carried out. Bada bing, bada boom. That's all you need to know. And that, my friends, is probably about as much as we're as we're going to get done tonight, because as I mentioned, it has been a long day for me, and I have had zero downtime. So I hope you appreciate all of this. Thank you very much for tuning in. I really hope this has helped you out. I will say, right, the more stressed out you are, the worse you're probably going to do in the exam. Okay, so if possible, just chill out a little bit. Right, remember, it's a mock. Right, I want you to do your best, but remember, it is only a mock. Okay, so we've still got time to fix things if they do go wrong. Obviously, I'm expecting you all to do better than you did in the walking talking mock earlier, right? So we'll see how that goes, right? Just remember, with pseudocode, don't panic if you're not sure what to write. Just write it in English. Okay, write it in English in a structured way. Okay. If there's any sort of elements that you're not sure of, remember, don't leave any questions blank. If you leave a question blank, you're guaranteed to get 0. If you write something down, even if you think, oh, this is stupid, right? If nothing else, it'll give me a laugh, but it might also get you some marks. Okay, so that's pretty much it. Okay, we have been streaming for nearly 2.5 hours. That's longer than I expected, but I think it's been pretty productive. The video will remain up on the YouTubes, so if necessary, when you get closer to your real exam, you'll be able to rewatch it. Obviously, nearer the time, I'll be doing some other learning live streams as well. So thank you very much, everybody. Best of luck tomorrow. And after the exams finish, feel free to come and speak to me and let me know how you did. That's that. Boom. So, oh god, thanks for the terrible jokes as well. We've had a few of them. Cool. I'll see you all tomorrow. Get a good night's sleep as well. That helps. That helps a lot. Goodbye.